Okay, question 12. Now, at first glance, this doesn't look too bad, guys. It looks like very, very chain rule-y to me. Like you're asked for dy dt, you've sort of got dx dt, you can get dy dx. Looks pretty good. But then you very quickly discover that it ain't so good, and you've got to really think it through. But what you do, like all these things, what I do is I just put one foot in front of the other until I discover the snags, and then I solve them. So hopefully you can do the same. So I worked out for this, it was chain rule-y, so dy dt is what we've got to work out. So let's make a statement, chain rule-ish, that dy dt is dy dx times dx dt. Alright, well that looks pretty good so far. Now, we know that y is 4 cos x, and therefore dy dx is going to be minus 4 sin x. Well, that's pretty straightforward. So then you substitute x as pi on 2 in there, and you get dy dx as minus 4 times 1, which would be minus 4. So far, so good. Now we've got to get the other part of it happening, which is the dx dt bit. And that's where it's not quite so easy. So, alright, let's make a start though. We say that dx dt is 3e to the 2t, but guys, we can't evaluate that because they don't give us the value of t. They just give you the value of x, which is pi over 2. So this is where it gets the first stumbling block occurs, okay? So what we need to do is we need to know dx by dt when x is pi on 2, as I was saying. So if we're going to do that, we've got to somehow crack the code and unravel this, and probably the best way to do that is to get x in terms of t, and you'll notice they've given you some initial conditions up here, so that's a bit of a hint. So let's try and anti-diff that. So if dx by dt is 3e to the 2t, therefore x would be 3 over 2 e to the 2t plus c, and putting in the initial conditions when x is 3 over 2, t is 0, you'll get that, and you can solve it for c. c is 0, guys. So therefore x is this beastie. Now, this is looking a little bit more promising. We know that x is pi on 2, so then how can we get the t thing unravelled out of that when we know x is pi on 2? Well, t would be the only unknown, wouldn't it? But let's go for it and see where that takes us. So therefore, when x is pi on 2, we know this is occurring, yes. Now, by just doing a little bit of lateral thinking, you can see that we've got to get dx by dt up here is 3e to the 2t. Now, we've eliminated everything but the e to the 2t up here, in this equation I mean, and therefore if we just got e to the 2t without trying to solve it for t, just e to the 2t is good enough, because we can see that e to the 2t is pi on 3, and therefore dx by dt is 3 times that, which is pi in the sky. Good old pi. So now, guys, we are 98% there, you see? Because, going back to the chain rule equation, dy dt, which is what we're supposed to be working out, is dy dx times dx dt. We know what dx dt is now. It is pi, and dy dx, what was that? Minus 4, wasn't it? So therefore we've got minus 4 pi, and that's the answer, and that's C for you and me, which does fill us with glee. So on to question 13. Let's have a look. If the equation f of 2x minus 2f of x equals 0 is true for all real values of x, then the rule for f could be... Well, guys, when I look at this, I look at all these offerings here, I think, yeah, well, this just instinctively looks to me like it's got to be some linear thing, really. It looks very linear. So I'm instinctively drawn to this one here or this one here, but more particularly to this one here, which has just got a coefficient of 2, and I'm just going to test it out and see whether it works. So yes, looks linear. So now let's have a look. If y equals 2x, then f of 2x, instead of being 2x, it'll be 2 times 2x, which gets you 4x, yeah? Now, on the other hand, 2 times f of x equals just 2 times 2x, which gets you 4x. See, exactly the same thing. See, my instinct was right. So therefore that's C. That comes with experience, just looking at those things from doing a lot of practice. You just get the radar for that, you know, what you think it's going to be. So, yeah, that was fine, that one. All right, question 14. Let's have a look. consider the graph of y equals 2 to the x plus c, okay, where c is a real number. The area of the shaded rectangles is used to find an approximation to the area of the region that is bounded by the graph, the x-axis, and the lines y equals 1, x is 1 and x is 5. Right, if the total area of the shaded rectangles is 44, then the value of c is. Alright, I think I get this. I can't think of an easy way to do this on the calculator. I think it's probably just quicker to do it by hand. Let's have a look. So this rectangle has a height of 2 to the 1 plus c, this one 2 squared plus c, this one 2 cubed plus c, this one 2 to the 4 plus c. Okay, we're obviously using a left-hand estimate because the part of the graph which touches the actual curve of the function, the side of the graph which touches the actual function is the side that we use for our approximate height. Okay, so this is a left-hand estimate. Now, let's just run quickly through it. We know that the area, therefore, will be the height times the widths of all those 4 shaded rectangles. So we've got 2 to the 1 plus c times 1 plus 2 squared plus c, which is 4 plus c times 1, and so on. Now, if we just simplify that, it's going to be very easy, guys. That comes to apparently 30 plus 4c, which is equal to 44. So it's very, very simple to solve that for c. So 4c would equal 14, therefore. C would be 7 over 2, and is that somewhere? It's D. Whoopee fills us with glee, so D is our answer, okay? Okay, question 15. So let h be a function with an average value of 2 over the interval from 0 to 6. The graph of h over this interval could be. Well, let's have a quick squiz here, guys. What I do with these things, I imagine if this was a cross-section of a mountains and valleys, okay, we're looking at some mountains and some valleys, and if we were to basically shave off the top of the mountains so they fitted exactly in the valleys so that we would have nice level ground all the way through the mountain range, that's what the average value is. Now, this one here doesn't look very promising because we've got 2 mountains and only 1 valley to fill in. So that's not really inspiring me much. This one here, if I went around about here, well, no, if I shaved that mountain off there, I chopped it off at about there, it's not going to fit exactly well into these gaps these gaps here. See, from here to here, and from say there to there up to where x equals 6. No, it's not going to go. It just doesn't look very inspiring. This one, no, I don't think so. Maybe, but probably not. Let's just reserve judgment on that one. This one here looks okay. Now, if you get these slanted straight line segments, the average value is always the midpoint. So therefore, what's that? We're going from plus 6 down to minus 2. That's a span of 8 in the y. So if we take the midpoint of that, 6 plus negative 2 is 4, and then therefore the midpoint therefore is where y is 2. Okay, so if you had there y is 2. Now if you shaved that mountain off there, it would exactly dump into that valley there, and you'd have a straight bit of road all the way along there like that. I think that's the one. I think that's the one. Yes? See? You see what I mean? If you shaved that mountain off there, and this was a little hinge, right, like there, you could rotate that round there and flop it straight into that valley, and it would fill in it exactly, and you would have a straight horizontal stretch of road all the way there through there. This one here, if you do the same thing there, you've got from 0 to 8, therefore the average would be basically 4, so that's no good. See, same procedure, but it gives us an average of 4 and not 2. So therefore C is the answer, guys. Okay? So let's have a go at question 16. Now, let's just assimilate the question. We've got a graph where we've got from 1 to 5 in the x, goes to their real equivalence, where the function is square root of x minus 1. Okay? Now, what are we supposed to be doing? Which one of the following definite integrals could be used to find the area of the shaded region being here? Okay, well, this I can't see that this is going to be any easier with a calculator, so we just have to use our head for this. So, having had a good look at it, we can try it with vertical rectangles. I'll show you what I mean. and see if that works. And if that doesn't work, we'll try some horizontal rectangles and see if any of the options are there. So this is a line x equals 1. This is the point 0 and 2, and that's the line y equals 2. And if we work out this coordinate here, that's going to be 5 and 2. Okay, now this is the vertical rectangle approach. I always teach my students to use rectangles because that's what integrals are. They're basically a sum of a whole lot of rectangles. So you never ever lose sight of the fact that that's what we're doing. We're summing up a whole lot of little rectangles which are actually infinitely thin. So with vertical rectangles as shown, what are we doing? We're getting the area would be top minus bottom, that's in terms of a y, that's the height. This dx thing, delta x thing, is the width, and we're going from x is 1 to x is 5. Now, if we scan down the options there, it doesn't look like it's there. What they've tried to do, they've tried to trick us with number c, but they've just gone from 0 to 5 instead of from 1 to 5, see? So that's no good. We're not going to fall for that one, are we, guys? No way. So now we just think, okay, we'll morph into horizontal rectangle mode now. So with horizontal rectangles, now here they are here. Now what we're going to do here is we're going to say the area would be, okay, the height, if you like, on its side is this minus this, right? In other words, I've just called that delta x being the sort of the sideways height of the rectangle, and the height of the rectangles is going to be the delta y, okay? So this means in order to do this, we've got to get this x2 minus x1, or if you like delta x height here on its side here in terms of y, because we've got to integrate with respect to y. So therefore we need x in terms of y. Let's do that. So if y is the square root of x minus 1, we're going to make x the subject of that. Therefore x is y squared plus 1, isn't it, guys? Yes, but we have to do, so that's what x is here. Okay, that's y squared plus 1 minus this bit here gets us the sideways height of that rectangle, if you like. And we've got that, okay? We've got x2 minus x1, okay, if you like, in terms of y, then integrated with respect to y, so that bit there is the height on its side, that bit there is the width, and we're going from y is 0 to y is 2, isn't it? Aren't we? Yes? Okay, so therefore we get that, and that's what we get. But that isn't there. But, guys, that is there. That is there. You have a good look at the options there, and you'll see that they're being very, very sneaky. But basically, if you have a close look at it, it's basically here, hiding as x squared integrated with respect to x. Isn't that nasty? Yes, very beastly. But see, it doesn't matter if you do x squared with respect to x, or u squared with respect to u, or, you know, Calathumpian squared with respect to Calathumpian. It really doesn't matter. It all comes out all right in the end. So they've tried to disguise the right answer by putting an x in there to trick us, but of course it didn't work, did it? We know that that's the same as option E, so therefore we're going for option E, and that does fill us with glee because we got the right answer. Yes. Okay, question 17. A and B are events of a sample space. Given that probability of A given B is P, probability of B is P squared, probability of A is P to the 1/3, then probability of B given A is equal to, oh my goodness. Well, come on, we'll do the formula which works in that situation, which is the multiplication formula, and it goes like this. The multiplication rule says that the probability of B given A is probability of B and A over probability of A. So let me see, have we got our ducks in a row for this? Well, what do we know and what don't we know? We don't know that by the looks of it, do we? No. We do know probability of A, though. That's P to the 1/3 by the look of it. Now, it's confusing, isn't it? Now, let's have another look and see what they do give us. They're giving us this for some reason, so we could probably put that in a formula and see where that takes us, right? So, yes, probability of A given B is probability of A and B over probability of B. So it seems to me, guys, that they gave us this, that's the left-hand side of that equation down here, and they also gave us this, so we can work out this one. No problem. Then why don't we just put it in there, and I think Bob might be our uncle. Yes, there you go, Bob's your uncle. PR of A and B is P cubed. Now we can plug that in the formula up here, and I think the answer comes out very nicely. So therefore the probability of B given A is P cubed over P to the 1/3, which would be P to the 9 minus 1, that's P to the 8 on 3, wouldn't it? Yes, and that looks like our answer, and that's D. Well, how about that? We got the answer. Beautiful, great job. Question 18. Right. So g of x equals the log of x base 2. X has to be greater than 0. Which one of the following equations is true for all positive real values of x? Alright, well come on, let's grit our teeth and do this, guys. It looks pretty awful. Just cast your eye down here. Look, the left-hand side of all these options is the same. So that's got to be our clue, guys. That's what we've got to use to try and get to the correct answer for all of these 5 options. So let's go with this. So g of x is log of x base 2. So we'll work out 2 times g of 8x and see where it goes. I don't see the need to use the calculator. I think it's going to be pretty simple, actually. So therefore 2 times g of 8x is 2 times the log of 8x base 2. Well, what can we do with that? We could probably call this log of 8 plus log of x, all multiplied by 2. Why don't we just see where that goes? Well, that looks alright, doesn't it? Because we know that the log of 8 with a base of 2 would be 3 because 8 is 2 cubed. So let's go with that for the next line. Oh, and we could also say, yes, because this is this one here is really the log of x squared, if you want to put that 2 back over there. And that's looking very, very promising, I think. Ooh, look at that. Look at that. That looks exactly what we want. That was very easy, wasn't it? So the answer's B. Yes, sirree. Okay, question 19. Let's just take in what we've got here. We've got part of the graph of a function where it goes from 0 upwards is f of x equals something quite revolting, e to the x root 3 times sine x. Well, we need a calculator here, guys, if ever we needed one, is shown below. The first 3 turning points are labelled T1, T2 and T3. Alright. The x-coordinate of T3. Alright, look, I think we go straight for the calculator. I think we put it in as a function and then we differentiate it. Let's see what we get, okay? So there you go. And so I've put it in as f1 of x, and I've said solve the derivative of f1 of x equals 0 for x, yes? And I get this funny looking thing, of course, because I'm dealing with a trig function here. Now, it seems obvious to me, guys, that if this was 0, well then you'd get minus pi on 6, which is no good to us because we have to have a positive value for x. If it was 1, if n1 was 1, this is just a parameter, this thing, from the calculator. So if you picked a value of 1 for this parameter, you get pi minus pi over 6, which would be 5 pi on 6. That's positive, yes? So it's the first positive value that we can get with a 0 gradient, right? What about if this parameter was 2? That would be 2 pi minus pi on 6. So that would be 11 pi on 6, wouldn't it? Yes, it would. And then the third one is going to be 3 pi minus pi on 6, which would be 17 pi on 6. And is that there? Yes, it is, and it's D. There you go, D's the answer. That was nice and easy, wasn't it, once we worked out what to do? So that's question 19 done and dusted. Question 20. Oh no, we've got a transformation one. Students hate these. But look, the way I do them, I highly recommend the technique that I'm about to show you. It just demystifies everything and makes everything simple. So we've got a transformation T such that x and y's map to wherever they want to map to. That means x dashed y dashed, the transformed x and y are transformed according to this algorithm over here. Okay, now, but this is the curly bit. Okay, so we're saying maps the graph of the function f some function f to the graph of y equals x squared. So in other words, we're mapping to the simple base model quadratic. So we're going from complicated to simple, which does students' heads in. So therefore they're asking us for the original function, which was mapped by this beast to this simple base model template quadratic, and they're asking us for what the original function was that got morphed into this. Now, pay attention, watch this. This is how I do them, and it just saves the day. Now, the transformed function, I always use dashes. Okay, so y dashed equals x dashed squared. That is the transformed function, hence the dashes, right? Now, let's just unravel that algorithm there. We've got x dashed up here is 1x plus no y plus 5, aka this, and we've got y dashed is no x minus y plus nothing, right? Now, that's the key to everything. That is the key to everything. So all we've got to do, guys, is substitute this x dashed, which is really this, okay? Right, in other words, we'll put x plus 5 in here for x dashed, and we're going to put minus y up here for y dashed, and that'll get us the original function. There it goes. So what we're saying is, therefore, instead of y dashed equals x dashed squared, we're saying minus y, aka this thing, instead of y dashed, equals x plus 5 all squared instead of x dashed all squared. And there it is. It's as simple as that, guys. It's easy as when you do it that way. And that's A. Hooray for A, and we've done it. Alright, question 21. Let's have a look. We've got a cubic function. There it is. There's the cubic, where a, b, and c are positive constants, and it has no stationary points when. And we've got all these options involving c. Well, no stationary points to me says we've got to do the derivative, and the derivative will be a quadratic. And okay, and I think I know what to do. It's a discriminant question, actually. I think I can see a discriminant very, very clearly coming up on the horizon. So there's that's the gradient function. Now, if we've got a stationary point, that thing's supposed to equal naught. Okay, so that's what we would be getting there. But of course, now if there's no solution to that, in other words, no stationary points, therefore we can just use the discriminant and make it less than naught. Okay, so there's the discriminant. And what we're saying is that that thing has to be less than naught for no solutions to a quadratic. Yes? So let's just unravel that a bit and have a look at it. It looks like, very interesting, 12ac has to be greater than 4b squared. Now all these options are in terms of c. So all we've got to do now is solve this for c. And we're home and hosed, guys. So it looks like c is greater than b squared over 3a. Now is that somewhere? It is, it's D. There you go, we've done it. We've only got one more question to go. My goodness, we're flying. Okay, last question, question 22. Now, usually these questions cause fear and trembling because they usually throw the book at you for question 22. But so let's have a look and see if it's really impossible. It doesn't look like it because it looks like a normal distribution thingy. Butterflies of a particular species die T days after hatching, where t is a normally distributed random variable with a mean of 120 days and a standard deviation of sigma. Looks like this is what we have to find out, guys. If from a population of 2,000 newly hatched butterflies, 150 are expected to die in the first 90 days, if that's the case, then what is the standard deviation? It doesn't look very hard at all. I think what we can do here is we can work out the proportion that 150 is of 2,000, because that's going to be our probability of dying within the first 90 days. That seems to me to be pretty straightforward to do that. Now, 150 over 2,000 is 0.075, so that's our proportion, aka our probability that the butterflies are going to last up to and including the 90th day. Alright? Now, what I'm saying here is I'm going into the calculator, I'm getting the inverse normal for a probability of 0.075 with a mean of 0 and a standard deviation of 1. That is the standard normal. I'm getting a z value of that, right? Now I'm saying, okay, look, x is my 90, so x minus mu over sigma, which I'm using x for, that'll be my Z value, which I got up there, okay, up here, right? So I'm just saying I want this minus this over this equals that. I want to solve it for X, which really means I'm solving for sigma, which gets that. And is that up there somewhere to the nearest day? Did I say to the nearest day? It's closest to, yes, closest to D. It's D. There it is. There it is. Fantastic. All right. So that's it. That's the 22 multiple choice questions from exam 2 in 2013. And I don't really think they were all that bad this time. What do you think? You have another go at them and make sure you can do them. And we'll catch you in the next exciting instalment. Okay? Bye for now.